Decorum in the courts. Thank you. Hello, good morning. My name is Christina Lee, and I'm an Android developer at Pinterest.
And hi, I'm Huyen and I'm yelling right now because I don't have a mic, and I'm an Android developer at Trello.
And we just want to caveat that if you're in this room and you know Kotlin, my goal is to make this the most boring conference talk you've ever heard in your life. And the reason for that is that we're not here to do advanced Kotlin features. What we're here to do is quote-unquote zero-day learning for people who have never looked at Kotlin before and want to go in and try it for the first time. So if you leave, I won't hold it against you, we'll still be friends, but I really want to emphasize that this session is for people who have never seen Kotlin, and I'm going to do my best not to leave any weird phrases that the advanced Kotlinites are excited about, but that beginners might be scratching their heads over. So that's my warning. There we go. All right. I got you already. 3 down, only 50 more to go. Now, just to show you what's going on today, we have this sample app, and it's important to me that we had a sample app that demonstrated a lot of technologies that everybody here is presumably using in their own apps at their own companies. And so there's Dagger and Retrofit, and it's Huyen's project, which is why I look at her. There's the repo patterns, just using RX. It's everything that you would expect from a modern app, and because of that, we're going to run into a lot of cases that you'll also run into should you ever do a Kotlin conversion. So to get started, this will be completely live coding. Yeet already said he would throw tomatoes at us. We did a special request for vine ripened and organic only. But if anything goes wrong, you're more than welcome to throw tomatoes or clap for us because our egos are hurt. So with that, let's go ahead and get started. And the very first thing is this is a Java file, and it looks hopefully as you would presume it would look, nothing crazy here. And we're going to go ahead and we're going to take the dive, and we're going to say convert Java file to Kotlin file. Step 1. All right, and we're done, we win. Except for, woo, production. Except for, of course, like we have this compilation error right off the bat, which is always a good omen. That's how you want to start. And I'm not going to get into why this is happening because Huyen is going to cover it later, but I'm just going to go ahead and get rid of it and just make it a single underscore, which is what it should be in this case. Back where we started. Okay, so to get started, I'm actually going to dwell on this first line because there's a lot of information packed into a single line. Now, first and foremost, if I go ahead and open up the Java version of this, you're going to see that it was public abstract class. And if I come back in here, it's abstract class. And so you're like, hey, you destroyed something that I really needed. It's important for this to be public. So you go in and you type public, and it says, hey, you actually don't need this. If you come over here, it's like redundant. And the reason it's redundant is because public is the default modifier in Kotlin. And so if I go ahead and show the other modifiers, top-level modifiers, you'll see that public's in there, and it's marked as redundant. You don't need it. It's by default. You also have private, which means that it's seen in this file. And you have internal, which means that this can be seen in this module. Now, these are top-level because Kotlin allows you to put things at the top level of a file, but that doesn't mean that there's not also some stuff in here. So let's go ahead and check those. Public is still there, nothing surprising. Private is still there, but now it means it can be seen only in this class. And then internal is there, and that's a little more complicated, which is basically that anybody in the module that can see this class can also see all internal members of the class. And last but not least, we now have this fourth one, which is protected. It means that it's private, but subclasses can also see this field. So those are the visibility modifiers. You don't have to memorize them. I just want to give you a place to Google should you ever need something. And like internal might not be familiar. It's not really a concept that you have if you're working in Java. So giving you a starting place that's basic enough to not overwhelm you, but gives you an idea of what to Google if you need to. So let's go ahead and clean this up. All right, so we don't have public. Let's dive into abstract. The only thing that I want to say about abstract is that it's exactly what you're already using. And the reason I want to say that is because I don't want you to think that you throw out the baby with the bathwater. So if I do like some model here and I do like my Unsplash model, okay, great. And then I do class, like some list fragment, and I can't type, so that's awesome. And it does Unsplash list fragment of some model. Whoop. you're going to see that it gives you exactly the error that you would expect. And it says, hey, this is an abstract class that you're implementing. You need to implement its members. We go ahead and do that. Everything's great. So I say that only to re-emphasize that when you convert a file, so much of your knowledge is still applicable, and a lot of these concepts are still the same and what you're used to. Okay, so public and abstract, class is hopefully okay. You may come upon this colon. I was always saying semicolon, but I got it right this time. And in the Java version of this, of course, it's going to be an extends. And so there's not much for me to say about this except for that where you used to have extends, you now have the colon. So anytime you're implementing or extending an interface or class, you're using a colon now. It's about as complicated as that. Have your one-to-one mapping. Okay, now unless you're really, really observant, one thing that you might not have noticed about this line is this kind of constructor invocation hanging out on fragment. And so we'll go ahead and talk about that. And I'm actually you don't need to know it for this file, but I'm gonna dive into a little toy example because I think it's something important to know in other files. So if we get started, let's say that we have some class animal. I can leave it like that, it's just an empty class, so that's fine, but it's a little boring. So let's go ahead and say, in my world, animals have legs. And I know that's really judgmental, and I'm a bad person, but you know, we're gonna roll with it. So animals have legs, and this is great. And we have, if we want, we could put some class body here. And right now it's empty, but if we wanted to do some initialization, say we can add an init block. Okay, but what's interesting here is that this is something called a primary constructor. And if it doesn't look like a constructor, you can go ahead and make it look a little bit more like a constructor by using explicitly the constructor keyword. You don't actually have to do this unless you want to maybe change the visibility of it, have a private constructor, or do something like, let's see, JVM overload seems good. Cool, something like this. If you want to annotate it or change its visibility, you need that constructor keyword. Otherwise, you can just go ahead and keep it unmarked. So I used the word primary constructor, which I hope makes you wonder, what is a secondary constructor? And you're in luck, I'll tell you. I got your back. Okay, so this is something called a secondary constructor. And you know, animals, like I said, they have legs, so I want to go and do that. But maybe this is also a type of animal that has fur. So I'll do fur type, string. Please never do this in real life. It's terrible. String is not a good type. And then I go ahead and pass this through to primary. Now you saw that before I did this, it was erroring. And the specific error is that you have to call through to that primary constructor. Primary here is basically saying you need at least this to have this class. And so sure, if you want to give me extra information, by all means, use the secondary constructors, but you have to give me at least this. And it's worth noting that you can take away the primary constructor and have an implicitly empty one. It's still there, it's just empty. And so here, you don't have to pass through, it's compiling. But if you have something defined here, you do have to call through to it, otherwise you're gonna get an issue. So, legs, there. Now, while I'm on this topic, I'm gonna detour a little bit. And I'm going to come up here and show you something that might be very Android specific. Let's go ahead and import these attribute set. There we go. So you can see in the animal class that I'm using this because I have a primary constructor and I'm going to pass information through to it even when I have the additional fur type. But for something like a view, this is a situation where you have a superclass. And so you'll notice here that we're actually using super where before we were using this. It's worth noting that if you try to do this and super, it's going to complain and have a compilation error. So don't do that. But I just wanted to point out that it's not always just this for a primary constructor. You can also pass through to super if you're doing something like views. Okay, that was our field trip. Now we're back into it. One thing that I want to point out while we're here too, now that we've looked a little bit at primary and secondary constructors, is the scope of things as you construct classes. So we have this legs value, and if we want to use it, you can see that it's in scope here, and that's awesome. And actually, it's in scope up here too, so like legs plus 1, I don't know why you would ever need this, but if you do, you can do legs plus 1. And this is in scope 2, hooray, we're winning at life. However, I know, there's always a but when I make that statement. If you want to do like some function down here, you say, I want to use the legs for something, and you try to use them, you can see that that field that we added is in scope, but legs itself is not. And a lot of times you need that information later on in your file. And so how would we do this if we were not in Kotlin world? Well, we would probably do something like val legs int, and then we have our init, and then we say this dot legs equals legs. And like, okay, this is fine. We see this code everywhere. It's all over a lot of our files too. But we're already seeing that there's a warning here, and what it's saying is that we can combine the assignment with this declaration. So join declaration and assignment. And this is okay too, I guess. Like it's not terrible, but we still have this repeated legs and int. We're already doing it up here. We're saying that there's this value legs and this is its type. And so the idea that we're repeating it down here is kind of absurd too. So actually we can go ahead and just get rid of that altogether and do something like this. And now if you go back into our example and you do find something, oh, please don't do that. Okay, we have some fun, and we try to do legs. There it is. And it's in scope. You can see that it's treating it exactly like legs plus 1. So these are now acting similarly. And worth noting, of course, if I take this away, again, out of scope. If it's here, it's in scope. Now, val can also be var. It's the difference between having a mutable reference to something and an immutable reference. But the general gist is that you can do this all in one go in your primary constructor. Now, it's worth pointing out, though, if we did that secondary constructor where we have legs, int, and then fur type, string, and then we go through, I can't spell string, So we have that. I actually cannot do the same here. So if I try, well, let's do it on fur type just for some variety. If I try to do this, it's going to error. And if you think about it, this actually makes sense because you don't have to call this secondary constructor. If I go and create the animal class, I can, well, let me put it in a val. Val something, my favorite word, equals animal with maybe 4 legs. I can do this and I don't have to pass it a fur type. I can. But I don't need to. And so it wouldn't really make sense to add a val here because if people don't actually call that secondary constructor, then like what happens to that field? Does it exist? Does it not exist? Now your class needs to know how it was constructed. That's kind of absurd. So you can do it in the primary constructor because everything has to call through to it. You cannot do it in a secondary constructor. All right, I think that just about gives you everything you need to know on day 1 for constructors. So we'll move on to our nice butter knife example. Here we are. It looks complicated, which is exactly what we want when we're learning something new. There's this internal word, which, as we already know, it's a visibility modifier, so okay, that's all right. And actually, I'm going to use a little cheat code right now and say that there's some indeterminate behavior around butter knife with this internal modifier. And so I'm going to go ahead and just delete it. and this is one of those things that on day 1, if you ran into the sort of bytecode issues that we were having when we practiced this, you would Slack someone or you would post it on Stack Overflow, and then we would answer and tell you why it's happening. But I really don't want to go down the rabbit hole today about what was going wrong. The TLDR is that with internal, it was generating a private field, and so butter knife can't work with private or static fields. So TLDR. Okay, so cheat code, got rid of internal. We still have this really complicated looking line, which is great. Now, I'm going to come over to the question mark. If you've heard anything about Kotlin, it's probably this question mark thing. And the question mark thing references that Kotlin has the idea of typed nullability. And it really is a question mark. You're like being like recycler view. And what that means is that it can be there, or it can also not be there, and it could be null. And so it really is a question of like, is this thing here? I don't know. I don't have any certainty. And so if I do something like this, I can't assign null to it anymore. But if I add a question mark, it means that a null is okay for this type. Now, if you've ever talked to a Kotlinite, they'll immediately say you should get rid of all nulls everywhere forevermore. And I'm one of those people, so let's do it. This is going to be great. Yeah, you thought that I was going to like contradict that. No, absolutely not. So we go ahead and get rid of null, but of course now we have this issue, and the issue is that it's saying it's not initialized. So that's kind of a bummer, because we come down here and we look and we say, but it is being bound. But unfortunately, it's not being bound in that init block that we had talked about earlier. It's being bound in onCreateView. And we as Android people, we know life cycles, and so we say, but I know it's going to be here, I promise. And so if you ever think that you're smarter than a compiler, you have this great opportunity to prove it by using the word late init. And what late init does is it says, hey compiler, I know that it looks like this thing isn't initialized, but I can guarantee that before I use it, it will be. It's not going to be null. And so if you make that guarantee, you better be right, because of course what's going to happen is it's going to crash to punish you if you're wrong. So like be pretty confident. But you can do this, and you know, it also, while I'm here, I'll point out that late init, it doesn't make sense with a nullable type. So if you come in here and look at this, it's going to say, hey, make this not null, because like if you have a nullable type, you don't need a late init, because you would just set it to null to begin with. So late init, and that did not work as per usual. There we go. Late init is for if you know something's going to be there, but it's not going to be there in that init block, then you can say, I'll set this later. All right, we got rid of 2 nulls. I feel like we're well on our way to mastering the world. So let's just continue on to the third one. Again, this is an unbinder, and I would love to remove the types nullability from it. But I should probably do a little bit of investigation before I just willy-nilly do that. And so I'm going to go in and look at it and check out this function signature. It turns out that this says that it's not returning anything that's null. It says that unbinder is marked as unnull, or non-null. Unnull, yes, that's my new word. And so I'm confident too that this is going to return something that's not null. Also, it's being called in onCreateView, so I'm confident that it's always being called. So it is safe for me to go in and change this to late init too. Now, of course, we're going to like come down here and do the same thing, and it's going to be great, late init, all right, except for that it's not, so don't do that. And the reason that we don't want to do that is because sometimes it really does make sense to use null. And it pains me to say that, and I'm crying a few tears right now, but null is a tool like any other. And so if we go in and we look at subscriber and its uses, we can see that the only place that we assign a value to subscriber is in load. And if we go and check out where load is used, well, it's in the retry button, which, you know, they don't have to push a button, so there's no guarantee that's being called. And then it's over here in this if-else statement. And the if-else is saying, hey, if you don't have permissions, ask for them, otherwise you can load. But that means that if you don't have permissions, we're never going to hit the load block. And so there is no guarantee that load is ever going to be called, which means that there's no guarantee that subscribe is ever going to be set. So it really does make sense for this to be nullable. And there are cases where null does make sense, but you need to think through them. Like with unbinder, it did not make sense. In this case, it does. All right, moving on. We made it past the first 5 lines. Like, it only took 20 minutes. This is great. All Kotlin is like this. So, yeah, encouraging words. OK, so we're in onCreateView, and it looks OK. It looks like mostly like an onCreateView. But actually, if you go in and look at it, you see that things are all marked nullable minus layout inflator. And it's not marked non-null, but it's also not marked nullable. So I think we just go with non-null. And here you can actually see that it is marked nullable. So that's a little bit unfortunate because we're sure that this exists. And so we don't want to leave it marked as nullable because it adds the branching. Anytime you have something that's marked nullable, you have to handle both cases. That's a branch. And so that adds code complexity. So we can go ahead and remove that, and it still compiles. And if you're anything like me, then your immediate first instinct is to come over here and be like, let's get rid of all of them. It's fine. But of course, now it's not compiling because I've changed the signature. What it's saying is that it overrides nothing because the signatures are no longer the same. So it worked for this one because it wasn't annotated, and there's something called platform types. If you're interested, it's a fascinating topic. You can Google it or come up and ask us about it. It's Huyen's favorite topic. But we're not going to cover it now, but there are things called platform types which allow this to be both marked null and not and still compile. But with these ones that have annotations, they have to be correct. Now, you'll also see that the return type was marked nullable, and here we're saying it's not nullable, so we should probably go ahead and correct that as well. OK, well, the type signature matches, and the TLDR here is that until we get to a place where everything is annotated perfectly, you probably want to do some research if you're uncertain of a type signature. If you don't know what it's returning, then go ahead and look, and you can probably clean some things up and save yourself some agony later on. Now, you're going to notice, because I did that, we now have these nice errors saying you no longer need these double exclamation points. And so I'll get rid of them, but before I do, I kind of want to talk to you about what they are, not just want to willy-nilly kill things off. Favorite character. And so to take a look, it's basically we need to handle nulls, right? Like if we know something's nullable, we can't use it. So let me actually go back here and make this nullable again, and then try to do something with it. So if I do inflator dot anything, you're going to see that it's all grayed out. And the reason it's grayed out is I'm not allowed to work with something that's possibly null. And if I try to do it anyways, it's not going to compile. And so what you need to do is you need to tell your program how to handle nulls. You need a null handling policy. And a really bad null handling policy is this. You can go ahead and use it. It's not going to yell at you. But a better one is this. And you might be saying, okay, well, why is one bad and one's good? Well, let's go ahead and look at some of the decompiled code from this. So I went ahead and decompiled a statement that was subscriber exclamation dot dispose. You're going to see this later in the file. It was the simplest example. And what that produces, if you go and check the bytecode, is something like this. And it assigns it to this variable, and then it checks if it's null, and then it says, hey, throw an NPE, which is everybody's favorite word. It's the best party guess to have. And obviously this should make you scared, because the whole promise of Kotlin is, hey, I can give you tools that make sure that you reduce drastically your NPEs. And so this is not great that we literally have a line in our code that says, throw NPE, it'll be a party, it's fabulous. And so if you come up here and look at the one that I described as better, you can see that this is actually a lot of what you're doing in your Java code already, which is that we have something and we say, if the thing is not null, please carry out an action. And if it is null, then nothing happens. We just proceed along. There's no else here. If there was an else, you would have another part of this, but there's nothing. It's basically, if this is not null, do something. Otherwise, no op. And that seems like a pretty reasonable policy to have in most cases. Not all, but enough to get you started on your first day. Okay. So, and again, I just wanted to explain that before I remove it, because now that we properly did our types, we actually don't need this. I already removed it. So again, it was like this when that was nullable, and now the error here is that it's not necessary, because you can't force unwrap something that's never null in the first place. Okay, now you already saw this earlier in the presentation. If you click on it, it just goes right back to what you would expect, which is this class, the unsplash list fragment. But what I want to say just before I sign off and hand the mic over to Huyen is that there can be multiple thises. And so let me create a toy example of this. Array of 1, 2, 3 testing. And then let me create a new scope. So I'll do something like apply. You don't actually need to know what apply is. You just need to know that now I'm in a lambda, so I'm in some weird other world. And it's happening on an array of ints. And so if I type this, someone might say, oh, yes, it should be on an array of ints. And indeed, this does things that arrays would do, like have a size param. And so that makes everything makes sense there. However, you can also do something that's named. You don't have to give up scopes if you descend into the rabbit hole. And so here you can see that I still have access to that top level this by mentioning it. And if I put an autocomplete on there, you're going to see things like load, which is exactly what you would expect from this fragment. So again, are you going to need this on your first day? No, but I want to give you an entry point so that if you ever get into one of these situations, you know what to Google and you know kind of roughly what tools you have at your disposal. And while I'm here, again, this is totally irrelevant, but it's a common misperception that you can't return from lambdas. You can use exactly this, again, to return from a lambda. Huyen is going to talk about this, but I just wanted to mention that it's here. Again, not something that you would need to know on day one. It doesn't clean up any of this code, but it's something that in the future might be useful. With that, I'm going to hand over the mic, and Huyen's going to start talking to you about lambdas.
So, hello. Hello again. You can actually hear me now. And so to start off, I'll take you on a trip to Lambda land, as Christina mentioned earlier. So if you've done much with Java 8 or even have used retro lambda, you probably know what they are. But if you don't happen to know what a lambda is basically like a function literal. It allows you to define a function as an expression that you can pass to other methods. So what we have here is a retry button with a very familiar set on click listener. And rather than actually instantiating and passing a click listener, we're passing it a lambda, which contains all of our awesome click button behaviors. So I'm going to kind of take a step back. I'm going to say, sorry, Kotlin compiler, but I kind of want to do this my own style. And because I want to show you what a basic lambda looks like in Kotlin. So what the lambda looks like is it will have these curly braces. And then the first thing that will come will be the list of parameters that go to your function, that go to your lambda. And as we are in Kotlin world, the way that the parameters are defined are name first and then type second. And then you'll see this right arrow. And then you'll actually have like the body of your function, the actual behaviors. Now, there's actually some things we can do here to kind of tidy this up and make it more Kotlin-y. So you can actually see that Kotlin's kind of yelling at me right now. Oh, actually, never mind. We'll get to that in a second. But what's really neat with Kotlin is that there's a lot of type inference. The Kotlin compiler is actually pretty smart. And so because we kind of already know what the signature of the click listener is, that it takes a view, we can actually go ahead and not have to specify it. Kotlin's smart enough to tell, oh, okay, so that first parameter is probably a view. So that's the first thing that we can do to kind of make things a little bit neater. So back to that thing that Lint was yelling at me about. It actually is detecting that I never use the view inside my click listener, and that happens a lot, right? We tend to not need to access the view. So something that I can do is let Lint do its thing and rename it. So sometimes, when you're kind of creating a lambda and passing it to a method, you might not need some of the parameters that you have to specify. And to indicate that you aren't using one of these parameters, you can actually replace it with an underscore. Now, if you have a lambda that takes multiple parameters and you happen to not be using multiple of those, you can actually kind of go along and actually mark multiple of them as unused. It's just the first one will be 1 underscore. The second one will be, thank you, 2 underscores. And as you might guess, the third unused one will be 3 underscores. So that's what that is. So let's go ahead and go back, though. So there's a couple other things that are really neat about lambdas and things that you will see in Kotlin all the time. Let me go ahead and do something a little bit different. Let's say that we actually do want to use our view here, and let's say that when we hit the retry button, we actually want it to disappear, which is actually kind of good behavior. I probably should, I need to add that. And say that when we hit our retry button, we want it to disappear as we're trying to give our data a new load, so we want to set it to invisible. Okay, so here we actually are referencing v, so we put it back in. But we can actually still shortcut this a little bit in Kotlin. So when you have a lambda that has a single parameter, you can actually ask Kotlin to implicitly declare it for you, and I can actually remove this. And so I don't have that named parameter, but Kotlin will give it a name for me, and that name is it. That's a little bit rude and impersonal, but that is actually kind of like the default name that Kotlin will give your variables when you ask it to implicitly declare them. And if we go to the actual bytecode that gets generated in activity created, don't get lost. Where are you? On create view, or on activity created. Oh, it's on create view. That's what you said. It's way down here. Live coding. It's at the top. Okay, live coding is fun. So as you can see here in the actual click listener that gets generated, we can see that indeed our view is called it. And actually, if we go back, so that's what it looks like when you ask Kotlin to implicitly declare this variable for you. And just to kind of go back and hammer in the point, if I had actually declared the variable and marked it as unused and go back to on create view, you can see that here's again my click listener. And because I actually marked it as unused, it generates this poor no name name. It doesn't have a name. That's very sad. But that's what the actual kind of bytecode looks like when you use an unnamed or unused parameter. So let's go ahead and go back. So yeah, you might kind of be wondering to yourself where the parentheses are in this lambda. Oop, there we go. So it's kind of weird, right? Normally when we call a function, we kind of pass parameters into parentheses. And that actually is valid. If I put the parentheses back in to the onClick listener, that kind of is more familiar, right? It makes sense. We are passing in this click listener behavior into the method call. But what is really nice in Kotlin is that there's a convention called trailing lambdas. So if you have a method and the last parameter is a lambda, you can actually go ahead and declare that lambda, or you can actually pass in that lambda outside of the parentheses. And that's what that is right here. So that's our onClick listener. Now let's go down and see what else we need to change and clean up in our Kotlin file. So this is a little bit odd. I have a variable called activity, and I'm assigning activity to it. Cool. What's going on there? So let's go ahead and take a look back at the Java file where we got all this code. Okay, and go down to onCreateView, and the syntax highlighting is gorgeous because it just is. Here we go. Okay, so originally in our Java file, we did something like this, which is something that we do a lot, right? We have a getter, and in order for us to kind of not have to invoke that method all the time, we're assigning it to a local variable. And what happened here is that when we converted that Java code to Kotlin code, we kind of ran into something that is actually quite fun in Kotlin, is that when you declare a property in a Kotlin file, rather than having to have an explicit get this thing or set that thing, you can just refer to both the getter and the setter using just the property name. So really, on the right-hand side, this purple activity is actually the get activity from the fragment activity. It's just that I can use this really nice, much more abbreviated way of calling it. And on the left-hand side is still just a local variable called activity. And if I actually delete the code, this line of code, my code still compiles. And in these places where I'm actually referring to what was originally my local activity, it's now, again, calling that get activity from the fragment activity. So something that comes up a lot when you're first getting into Kotlin is, how about statics? How do I do statics? So Kotlin doesn't have statics per se, but Kotlin does have this thing called a companion object, which allows you to kind of do static-like things. So in my original file, I probably shouldn't have closed that. We'll go back to my Java file, and I can see that at the top, I have a couple of static variables, private static final int span count and some other things, and it's kind of just something that we're familiar with. But in Kotlin, number one, static-like things are declared at the bottom of the file rather at the top of the file, and I have this companion object. Isn't that nice? We have a companion on our little Kotlin journey. So the companion object is basically a singleton that belongs to that class, and within it you can declare properties, you can declare methods that you can call in static-like ways. So here, let me just do a quick example. And so if I wanted to call like something in my companion object in other Kotlin code, I might do something like this, /list fragment .span count. As you can see, static-like behavior in our Kotlin. Now, the tricky thing is when you start trying to call things from Java. So let me open up a Java class, my kitty class.
She named this.
I did. I named it. It had nothing to do with the actual application. She went with like animals. I was like, okay, kitties. So say I wanted to. Let me go back to my companion object, and let me add a new. We use opposite styles of scrolling, and she uses Vim and I don't, so I apologize. We're kind of all backwards on things. So say I declare like a new property on my companion object that I want to reference statically in a Java file. Let's say that I want to do fuzziness, and I want to reference this value in a Java file. So I can do /list fragment. Now the problem is that because in Kotlin this property lives in my companion object, I have to actually reference that companion object when I'm accessing it from a Java file. And not only that, because this is a property, in Kotlin I can, again, use just the name of it to refer to the getter and the setter. But in Java, when the bytecode actually comes out the wash, it actually is doing a getter and a setter. It's get fuzziness, set fuzziness. Man, I actually want to write an app now where I have a get fuzziness property. That's kind of awesome. So as you can see here, when I'm calling it from Java code, it's kind of ugly. I have that companion reference, and I have now like this kind of odd looking function call. So there's a few things I can do to fix this. So if my property is a value that is known at compile time, primitive or a string, I can actually add this really awesome const keyword, and I can omit the reference to the companion object, and I can get rid of the get and the function call. And now it looks a lot more like we're used to static properties in Java. Now, this works for primitives and string, again, compile time known values, but what if I have an object? What if I had something like, let's see, fuzziness levels. And I create a list of, do that, super extreme. It's so fuzzy. Now, say I actually wanted to, sorry. Fuzzy things are awesome. So this is an object, right? Its value is not known at compile time. And say I wanted to reference this from Java. I have the same kind of problem where I have this really ugly kind of call. There's some things that I can do to fix it, and that is with annotation. So if I annotate it with JVM static, that lets the compiler know that I actually want to reference this kind of in a static type way. Live coding is fun. And as you can see, I can omit the companion object reference, but I can take it one step further. And if I, instead of using JVM static, I use the JVM field annotation, I can actually go ahead and, again, get rid of the get rid of the function call, and I now have a much more kind of cleaner and more familiar way of referencing this field, because it's now treated as a static field. So you'll probably run into this because we all love static things. But so that is how you do static type things in Kotlin. Sorry, look at my notes. I don't have much time left. OK, so let's kind of blast through the rest of our file and get it looking nice and much more Kotlin-y. Oop.
Spoiler alert.
Spoiler alert. People helped us out. OK, let's go back to our Kotlin file. All right, so we're here. Let's go ahead and clean up. We don't like those null, non-null assertion, double, whatever you want to call them, double bangs. OK, so this is something that we use a lot, especially with like click listeners and things like that. A lot of times in Java, we want to, kind of have anonymous inner classes for maybe click listeners, or just really quick, kind of specifically scoped implementations of abstract classes or interfaces. And you can still do that in Kotlin. And the implementation is still pretty familiar, but a little bit different. So here I have this span size lookup that I want to kind of implement for my grid layout manager. And instead of doing like new grid layout manager .span size lookup, I'm actually using this object expression. And basically, you can just think of the object expression as just like an anonymous class. It's just kind of like this kind of singular like implementation of this interface or abstract class. And again, it's just object : grid layout manager .span size lookup. And then that's it. That's all you need to know to get your anonymous classes inside of sorry, double bangs everywhere, inside of your Kotlin classes. So you might notice something interesting is that these two variables here don't have types. And a fun thing about Kotlin is that there is type inference. The Kotlin compiler is pretty smart, and it can actually tell what the type of your variable is from whatever is going on the right-hand side. So that's why when Kotlin converted my file, it just kind of did a implicit inference rather than actually explicitly typing things. But sometimes in Kotlin, because things can be very brief and very concise, things can get confusing, and sometimes it actually is better to explicitly specify the type. So I'll give you a quick example of this, and it's a really crappy example. Please don't ever do this in like real life. But for the purposes of this demonstration, say that I wanted to dynamically create a linear layout. Go, and say I wanted to kind of do some initialization on it, because you should always set the orientation. There we go. So if the syntax is new to you, which it probably is, since you're all burgeoning Kotlinites, lazy is just basically allowing you to lazily evaluate a block of code. And so this won't get run until the first time that you call this linear layout. So yeah, but the problem with kind of type inference is that sometimes things can get confused. The compiler can get confused. So if I look at this looks pretty good, like kind of at the start, right? I've got my linear layout, I've instantiated it, I set it up, and now my linear layout variable has a nice new shiny linear layout in it, right? No. So if I actually go in and add the explicit type for this, oh no, it's erroring. So the reason that it's erroring is that with lambdas, it's actually interesting. The return type of a lambda is determined by the value of the very last statement. So if I look at my last statement here, I'm calling the orientation setter, which in Java has a return type of void, and in Kotlin has a return type of unit. You can just basically think of them as the same thing. And so when I leave out the actual explicit type, when I let Kotlin infer it, it's saying, oh, okay, you wanted unit or void here. So when I add the type back in, you can see that there's a mismatch here. So what I actually want to do to correct that is actually, again, just kind of call the layout here, which returns that linear layout as a value, and everything's hunky-dory. So that's just something to kind of remember, is that while it's really cool to start like using type inference and leaving stuff out everywhere, sometimes for readability and also for correctness, you might actually just want to go ahead and put it back in. Oh, and code reviews as well, that's true. And a lot of times, just like personally, sometimes if there's an API that you're not familiar with and you can't remember what the return type is, it can get really frustrating and confusing. That was like a big problem for me when I first started doing Kotlin. Let's see, what do we have next? We have not too much time left. I gotta blast through. Let's see, oh, right. So if I go down here, this might seem new to you. So I have, when I'm requesting these permissions, I have this kind of new array of method. And so arrays in Kotlin are kind of interesting. There's actually kind of two main types of arrays. There are boxed arrays, which look a little something like this. And the Kotlin standard library is really freaking awesome and has a lot of really handy methods in it. That's a technical term, really freaking awesome. Now I also have unboxed arrays, which look a little something like this, and there's still some more standard lib awesome to go with it. Now the difference between boxed and unboxed arrays is pretty straightforward. Boxed arrays are basically like this. They are literally arrays of boxed types. And unboxed arrays are just like this. They are arrays of primitive types. And in Kotlin, we have int arrays, we have double array, we have byte array. So if you see arrays in Kotlin and you kind of can see like there's like, it seems like there's two different kinds of those, that's what's going on. So we'll just leave that there. And we'll go down. All right, oop, non-null assertion operator gotta go. All right, so if we look at this code right here, we have a null check. And we still have a double bang. Did the Kotlin compiler make a mistake? It actually didn't. So what's interesting here is that this subscriber variable is a top-level member of our class, and that means that other folks out in the world on another thread maybe might be able to access and modify this value. So what's happening here is that Kotlin is adding the non-null assertion operator because even though we're doing a null check here, it's totally possible that another thread might come in and mess with our subscriber, and at this point it might be null, which is why Kotlin is like, whoa, 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 whoa. This isn't cool. We need to put in the non-null assertion operator here to make it safe. So what we can do to get rid of that stupid double bang is do something like we did before with the activity, so what we're doing is we're taking that subscriber getter and then assigning it to an immutable reference so that it's a final value. So it's basically like a final value, and we can actually now remove that. So what that allows us to do is we're taking that value, putting it into a mutable reference so that we can guarantee that between the null check and the actual invocation of that method, that value won't change. And so I'm running out of time, so I'm going to go ahead and hurry up here. So actually, I'm just going to go ahead. We're running out of time, so I'm going to do this. So if I take this away, and do something like this. Actually, shoot. Let me do this. OK, so what's going on? Lint is yelling at me again. And while I can do the null check just fine, there's actually a much briefer way of doing that. And if I let lint do its thing, I can do this. So what's really cool is that instead of doing null checks on a nullable value, in Kotlin we can actually use this question mark, which is something you might see a lot in a lot of places in Kotlin. And this is the null safety operator. And basically what that does is it kind of encapsulates that null check inside of itself. So when you add that null safety operator before a method invocation, it basically says, OK, if this method is non-null, then go ahead and invoke the method. And if it's null, then it no-ups. And I think that's it. OK, we're almost there. We're almost there before they start dragging me off the stage with a hook. Yeah. So there's one last thing. So the thing is with converting Java to Kotlin is that while you'll generally end up with things that are syntactically correct, there are things that might be either hard to read or hard to understand. And So here, a quick example. So if you're not too familiar with ArcsJava, don't worry. What I basically have here is I have a network request and a success callback and an error callback. Now, as you can see here, they're not lined up, and it almost looks like they're kind of in two different places. And that's because what's going on here is that my subscribe method here is taking two lambdas, one for the success case and one for the error case. And because, oh, the last parameter is a lambda, I'll give you that cool trailing lambda syntax that you like so much. And that's why that looks like this. And as you can see, it's a little bit disjointed and hard to understand. So in cases like this, just for readability, it might be great just to pull it back in and add that this and format it. Actually, let me do that. And then format it. And as you can see, sometimes you want to do these little cleanup things just for understandability and readability. And I think we got it. I think our Kotlin file is good.
Yeah, looks pretty good to me. You want to go through things?
Yes, we should. So basically, in the process of doing this talk, we asked for a lot of feedback because sometimes when you've been doing something, you kind of forget what was confusing to you. So we asked a whole bunch of very nice people to look at this raw, kind of slightly ugly Kotlin file and then let us know what was confusing to them about it. So thank you very much, all the people that took time and wrote us awesome kind of feedback and made suggestions on Twitter as well. So thank you to our peeps on the tweets. God, that's awful. For giving us this feedback, because this talk would not have happened without you. And I should probably leave the stage now, but thank you very, very much. Oh, and if you have any questions, we'll be around.